The second video for section 115 is going to discuss inverse variation. Now, two variables are said to vary inversely when they have a proportionality constant k such that k equals the product x times y of these two variables. So if we look at these examples here, 3 times 12 is 36, 2 times 18 is 36, 6 times 6 is 36, so forth and so on. So in this case, our proportionality constant is 36. So let's look at some examples of inverse proportionality. Boyle's law states that if the temperature of a gas is constant, its volume varies inversely with pressure. So we would write this as K is equal to V times P. Or if we wanted to solve exclusively for V, we see that V would equal K over P, where K is the proportionality constant. Now, if you drive on a daily basis, you've seen this before, the rate at which an automobile covers distance varies inversely with time. So in this case, is going to vary inversely, so R times T is going to equal the distance. In this case, distance is the proportionality constant. R in this case is the thing that's varying inversely, not the distance. Another example, in a wire of a given length, the electric resistance varies inversely with the square of the diameter. So resistance varies inversely with the square of the diameter. So K is equal to R times the diameter squared. Or if you wanted to rewrite this solving for R, K divided by D squared. So let's look at a few more examples. Charles' law and Boyle's law combined state that the volume V of a gas varies directly with its absolute temperature and inversely with its pressure. So volume varies directly with absolute temperature. So let's write that down first. K is equal to volume. If it's direct variation, we divide. And inversely with the pressure. So then we would multiply by the pressure. So again, take a second. This has two types of variation in it. We have that volume varies directly with temperature, so we divide, and then inversely with pressure, so we multiply by P. One more example. For two rotating gears, the number of teeth T for either gear is inversely proportional to the number of revolutions N. So in this case, K is equal to the number of teeth times the number of revolutions N. So suppose a gear with 50 teeth is rotating at 400 RPM, turns a second gear. We want to know how many teeth it needs to rotate at 125 RPM. So again, this is different than the proportions in the sense that we have products here instead of fractions. So we've essentially kind of jumped to the stage where we can just divide by our coefficient. And so T ends up being 160, and again our units in this case are teeth. So this makes sense. We need a gear that's bigger that will turn slower to get the 125 RPM. Now let's go back to that example that was on the previous page. Again, this one involves both a direct variation and an inverse variation. So I want you to pause the video now and try this example and then resume to see if you have the correct answer. So with this one, you should have found that your proportionality constant was P over V squared times R. So if we plug in our respective values, you should have found that P was equal to 480 watts. Now this concludes the second video for section 115. The last video will discuss joint variation.